Hey, let's continue with the morning quiz review for 7.2. Number 3, the base of a solid is enclosed by x squared plus y squared is equal to 16. We have a circle with a radius of 4. Find the volume of the solid. And for part A, we're going to be doing cross sections, rectangles whose height is 3 times the length of the base. Now, they're telling us uh, how to draw the base in which direction. But first, we have the circle here. This is our shaded region. X squared plus y squared is equal to 16. And we're drawing our cross section horizontally because this is our x-axis. Parallel, so we're going to go in the same direction. And we're going to do right minus left. So if we're doing horizontal, that means everything has to be in terms of y. So that means we have to solve in terms of x. So x squared is equal to 16 minus y squared. We're starting with this equation. We get x squared equals 16 minus y squared. So x is equal to plus or minus root 16 minus y squared. So we have this right curve, which is the positive root 16 minus y squared, and this left curve, which is the negative root 16 minus y squared. So if we do right minus left, we'll simply get root 16 minus y squared minus the left endpoint, which is of the base, which is negative root 16 minus y squared. So the two negatives cancel out. We get 2 root 16 minus y squared. Okay, and so now this will represent the base of our rectangle. So the rectangle is 2 root 16 minus y squared. However, the height is 3 times the length of the base. So we just have to do 3 times this value to find the height. So 3 times the value here, and this will combine to be 6 root 16 minus y squared. Rectangle is base times height. So we're going to get 2 root 16 minus y squared times 6 root 16 minus y squared. The bounds are from the lowest y value to the highest y value. This is a circle that's centered at 0, so our bounds will go from negative 4 to positive 4. So our volume formula is negative 4 to positive 4, area of our cross section, which is the rectangle. Combine these two, multiply this to be 12 times 16 minus y squared from negative 4 to 4. In our calculator, we're going to get 1024 cubic units. Okay. Part B, we have the same shape, but now our cross section is going to be equilateral triangles parallel to the x-axis. Again, the same setup as before. Here's the x-axis, parallel, the same direction. So right minus left, we'll use the same equations. So root 16 minus y squared minus a negative root 16 minus y squared. This combines to be 2 root 16 minus y squared. But now this is no longer the base of a rectangle. This is now the base of equilateral triangle. The formula for the area of equilateral triangle is root 3 over 4 base squared. Now the base will now be represented by 2 root 16 minus y squared. I'm going to pull the root 3 over 4 out as a coefficient, and our bounds are going to go from negative 4 to positive 4. Okay, we square what's inside the bracket. This will give us a value of 1024 over 3. Multiply this by root 3 over 4, and this combines to be 256 root 3 over 3 cubic units. Okay, part C, we have a right isosceles triangle whose hypotenuse lie on the base of the solid. But now our cross section will be perpendicular to the x-axis. So we're going to be drawing vertical, this vertical length, this vertical base. So we have to do top minus bottom. If we do top minus bottom, everything has to be in terms of x. So we're going to go back to our original equation, solve for y. So we'll get y is equal to root 16 minus, or plus or minus, root 16 minus x squared. Okay. This top graph above the x-axis will be the positive root 16 minus x squared. The bottom, the below the x-axis, will be the negative root 16 minus x squared. So we do top of the base minus the bottom of the base. Top of the base is at the root 16 minus x squared. Bottom of the base is at the negative root 16 minus x squared. So it'll look similar to what we've seen before, it's just that now will be in terms of x. So the two negatives cancel out to be a positive, so we add those together to be 2 root 16 minus x squared. Now this base will be the hypotenuse of our right isosceles triangle. And the formula for that is 1/4 hypotenuse squared. Okay, this is the area of a triangle adapted so that we can use the hypotenuse to find the area. So we simply replace 2 root 16 minus x squared in for the hypotenuse, pull the 1/4 out, and this gives us 1024 over 3, which we found from part B as well. So then 1024 over 3 times 1/4 combines and reduces to be 256 over 3 cubic units. Okay. Part D, we have semicircles. That's where it'll be similar to part C, where our base, our cross-section, is perpendicular to the x-axis. So here's the x-axis, perpendicular, it'll go vertical. So top minus bottom, again, we're going to have the same setup as part C. Root 16 minus x squared minus a negative root 16 minus x squared. Add those two together to be 2 root 16 minus x squared. But now this base will represent the diameter of a semicircle. So our area in terms of a diameter, using diameter to arrive at the area of a semicircle, is pi over 8 times diameter squared. And then replace diameter with 2 root 16 minus x squared. Pull the pi over 8 out. We're going to go from -4 to 4 as the bounds, the furthest left x value to the furthest right x value. And again, like before, this will produce 1024 over 3 multiplied by the coefficient pi over 8, and that reduces to be 128 over 3 pi cubic units.